Okay, you should know what pressure is. So pressure is going to be abbreviated by capital P, and you should know the definition of what pressure is. So you can see it's related to force. It's concentrated force. So the pressure of the Earth, Earth's atmospheric pressure, is caused by the force of gravity acting on all the air molecules that are above us. So there's something like 6,200 miles of oxygen and nitrogen on top of us. And the gravity of the Earth is pulling on all of that, and it's pulling it down on top of us. So that's the force that is causing atmospheric pressure. So you should know a little bit more about the Earth system. So as far as the atmosphere is concerned, you should know about the troposphere, because that's where Earth's weather takes place in. You should know about the stratosphere, because the stratosphere is where the ozone layer is located at, which protects us against ultraviolet light. Okay, what about the hydrosphere? So you should know the different places where water comes from. So there's water in the oceans, water in the lakes, water in rivers, water under the ground. You should know that most of that water is in the oceans, like 99% of Earth's water is in the oceans. Okay, you should know what the cryosphere is. So examples of the cryosphere would be at the north and the south poles, where you have continental glaciers, and then also on very tall mountains where you have glaciers. That's also considered part of the cryosphere. Okay, then you got the biosphere. So remember that life can be basically anywhere. You have life in the air, you have life in water, you have life on the land, you have life underground. So anywhere that you got life, that is part of the biosphere. Okay, then you've got the geosphere, which is going to be the solid part of the Earth, and that includes all the rocks and minerals inside the Earth, and it also goes all the way down into the core. So all of those different layers are considered to be part of the geosphere. So why is the Earth hot? So the sun heats up the outer part of the Earth, and then that's what drives the weather. Okay, then you've got the internal heat, which comes from three places. So the Earth was originally hot due to the impacts of all of those asteroids that made the Earth. So every one of those asteroids had kinetic energy because they were moving. And so that energy that was released heated up the Earth. Okay, but the Earth is also hot on the inside because of nuclear fission. So there's radioactive elements inside the Earth, and as they decay, they break apart into smaller nucleuses that releases heat. And so that also keeps the inside of the Earth hot. And then there was also some energy that was released as the heavier elements, iron and nickel, as they fell to the core, that released potential energy and turned it into kinetic energy, which turned it into heat. So that's called gravitational heating. So who cares? This heat is what's going to drive plate tectonics and is also what's going to be causing Earth's magnetism. So it's important that the inside of the Earth is hot. So how do we know what is inside the Earth? Okay, we're going to skip this slide, and we're going to talk about it in more detail when we talk about seismometry, so earthquakes. But for right now, we know that the Earth has different layers because we have monitored earthquake waves as they have traveled through the Earth. And so as they bounce off the different layers, that shows us where those layers are located at. So seismic waves, earthquake waves. Now, you got to know the different layers of the earth. So this is pretty important. So let's first talk about the compositional layers of the earth. So this means, what is the earth made of? And so you have a iron nickel core. You have a mantle that surrounds that, which is made of dense rocks, and later we'll find out what those are. Okay, and then on top of it, you've got a very thin crust. So if you think about the thickness of the shell of an egg compared to the size of an egg, that gives you a rough idea for how thin the crust is. And there are two kinds of crust. So you have the crust that is on the bottom of the ocean floor, and then you have the crust that is on the continents. So continental crust and oceanic crust. And later we'll talk about what those are made of. But relatively light density rocks that are resting on top of the mantle. Okay, now let's talk about the different layers of the earth based on state. So there are states of matter. So you have solid, liquid, gas, plasma. And then if you want to watch The Fifth Element, then that's, well, that movie, never mind. All right, so those are the four states of matter. And there's no gas inside the earth. And so we're only going to be considering the solid parts of the earth and the liquid parts of the earth. So that the core, which is made of iron and nickel, can be divided up into two parts. The inner core, which is solid iron and nickel, and then the outer core, which is going to be liquid iron and nickel. This is important because it's the movement of that liquid iron and nickel that produces Earth's magnetism. Okay, then on top of the outer core is going to be the mesosphere. Meso means middle. So this is the middle part of the Earth. It's going to be solid, but yet it can flow like a liquid. And which is, so we'll talk about that when we review for another video. Okay, but the mesosphere is important because as it is moving, as it is convecting, that's what's going to drive plate tectonics. Okay, then on top of the mesosphere is going to be the asthenosphere. So the asthenosphere is going to be slippery, and the plates, the lithosphere, is going to slide on top of the asthenosphere. And then the lithosphere is solid, and it's going to be broken up into plates, and then as those plates collide and move past each other, that's going to be plate tectonics. So make sure that you know all of these different layers, and also know the relative thicknesses of them, so that you can see, for example, that the mantle is much thicker than what the crust is. So the crust and the lithosphere are the thinnest parts of the geosphere. All right, so that concludes this lesson. All right, so stick around, come back, and we're now going to do lesson number 2.